Hello everyone. So I'm gonna present to you today the solution for the chessboard puzzle that I posted yesterday on the Discord. I'm gonna take like 5-10 minutes to explain it. This video is gonna be in 3 parts. The first part is 1. How to approach a problem like this. The second part will be the solution that I found, which is really kind of math heavy and complicated it's more of a general solution that I kind of found. And third will be the fancy, elegant, simple solution that pretty much everyone can understand. So I'm gonna have timestamp in the video, and yeah, that's it. I actually found out also that the person who sent me, like my friend who sent me this puzzle, actually saw it from Stand Up Math channel on YouTube, and three blue, one brown channels. Both did an amazing video explaining way better than what I'm gonna explain it now. But I'm gonna try to explain it like really beginner friendly. And try to understand what this puzzle is, right? What the solution is. So I'm gonna link those videos in the description if you want to check it out. Go check it out. These are like awesome channels. Right. So first of all, what's the puzzle? What is it, right? So you have this malicious, math-obsessed warden that has this chessboard and a bunch of coins, and you can imagine that in each of these squares there's a little compartment that you can hide a key in. So basically the warden will tell the prisoners the challenge. The prisoners can try to prepare a strategy, and then the challenge would start. So what the puzzle is, you're gonna have a chessboard like this, an empty chessboard, and the warden will place coins, either heads or tails, 1 coin on each square, and it could be anything. It could be random, it could be a pattern, it could be anything. You don't know, right? So the warden will place coins like heads or tails. Tail, head. There will be like coins here with either heads, then another coin. You know, it's gonna be this pattern here, and it could be any pattern. It could be heads or tail. You don't know. The warden's gonna place it when the challenge starts, so you don't know the pattern beforehand. So what the challenge is you're gonna have this chessboard with a bunch of coins, heads, tails, heads. I'm gonna speed up the video. I'm just gonna randomly fill it up. Alright. So what the puzzle is, you have this situation, you have a chessboard with a bunch of coins, either heads or tail, 1 on each square. And you can imagine a compartment where a key is hidden. You don't know which one, of course. And so how it works, the first prisoner will come in and will see this pattern. Then the warden will hide the key somewhere, let's say on this square. So this square has the little key and it's hidden under the coin. You can't see it, right? The first prisoner sees this and has to flip 1 coin and only 1 coin, so that, and leaves. Then the second prisoner will come in, will look at the board and figure out where the key is in only 1 guess, right? And that's it. That's the puzzle. If they succeed, they're free. If they don't succeed, they die. That, you know, so they have to succeed. At first glance, this challenge seems completely impossible, and that's what I thought too. Especially like the first prisoner, the 2 prisoner can talk about strategy beforehand, right? like, okay, we're gonna have a board with a bunch of coins, and we have to try to figure out how to, how can I flip a coin so that you understand the strategy, the where the coin is, where the key is. Sorry, so I flip a coin and one coin, and you have to figure out where the key is. The warden will hear your strategy and can either place the coin randomly or in a pattern that would defeat your strategy, right? But the coins are placed once the challenge starts. Nobody knows what the pattern is beforehand, and so the warden list is in. The first prisoner goes in. Obviously, the second one is still behind in another room. First prisoner sit down. The warden will place a bunch of coins, hide a key in one of them, and that's it. So right now, I just put a random pattern, right? Because it's gonna be like, if you cannot beat a random pattern, then your solution will not work every time. And that's the puzzle. That's like, the rules are really simple in some way, and now to figure out how can you beat that? How can you beat a puzzle like this? So now we're gonna go to part 1, how to approach this problem. So the first thing I did when I look at this puzzle, like, because the challenge is, you have, from what I understood it, right, you have this board of noise, basically, and you have the power to change one little thing so that the second person comes in, see the same noise, almost the same noise, except one different, and understand the position, the exact position of the key, right? Which is here in our case. But the second prisoner doesn't know that, doesn't know where the key is. So there has to be a transfer of information from a prisoner to the next, and that is done by the coin flip. And what's a coin flip? I don't know if I have to explain it, but like, if, for example, if I choose this coin, then this will not be true anymore. It's gonna be heads, and I did a coin flip. True, tails, right? Sorry, computer science speaking. So it's not gonna be tails anymore, it's gonna be heads. Okay, so what do we do? So how do I approach this problem? The first thing I did is try to do like the simplest case possible where that puzzle applies. And I figure out, okay, it's gonna be like 2 squares. So I have 2 squares, and I can talk strategy with my other prisoner, with my friend, and figure out a way to discuss on which square is the key, right? So one solution that I came up with, which is very, very simple, I say, okay, well, the second square here is gonna determine where the key is, because I have to do a coin flip, right? So I'm saying, okay, if this one is heads, then the key is in the first square, is right here. And I'm saying, okay, if the second square is tails, then the key is over here. So when the second prisoner comes in, see that the second square is tails, so that the key is under that square. So let's say the warden places the coins like this, right? Puts a key over here. I come in, and I know that the key is here, and I have to transmit that information to my friend. So what I'm gonna do is I'm gonna flip this coin to head, and when the second prisoner comes in, we'll see that that coin is head and the key is here. It's a very simple solution. So if the warden places the coins like this, it's already tails, the key, it's already correct. So I'm just gonna flip this one here, since we don't care about this one. I'm just gonna flip it here. So, and I still know that the key is in this square. because this is true. So I'm like, okay, so this is a very, very simple solution. There's only two squares, and what do I do now? So now let's start with three squares this time, and you'll see that this solution will kind of break almost immediately. Now we have three squares, three positions where the key could be in, and you have a random assortment of heads and tails here. What's a strategy that we can say? So there's three positions. So one coin cannot have information for more than two squares, because the one coin has it has either heads or tails, right? You have two states. You cannot have a third one, so you need two coins to have information about where the key is. You need two coins. So for example, we could say, okay, well, now you can count in binary if you want. So you have like 0 0, 0 1, 1 0, and 1 1. So with two coins you can have four different combination of these coins. And so you're like, okay, well, if it's 0 0, we can choose the same thing. Okay, we're gonna choose those two ones. If it's 0 0, then it's in this square. If it's 0 1, then it's in this square. And if it's 1 0, it's in this square. And okay, so the game will start. The game will start. He's gonna put heads, tails, and heads. And he's going to put the key here. Which is great, because now you're like, okay, so let's assume that tails is 1 and heads is 0, for example. So okay, so you come in and you see 1 0, and you're like, oh, 1 0 is the third square. So right now it tells that the key is here, which is not true. It's in the first one. So you can switch this one to 0. So you flip this coin, and the second prisoner comes in. Look at these two squares, and you're like, oh, it's 0 0, so it's in the first square. Everything good. But now if the warden hears this strategy, and you're like, okay, they're gonna choose the two squares, he can break it. He can break it basically right away. He can put the key in the first square again, right? And then put true everywhere. He's gonna put tails on every square. So now you come in and you're you're kind of in a situation now where you have 1 1, and now you need to flip a coin and somehow get to 0 0, because that's what you told. That was the strategy. You counted. You're counting in binary, but now you're stuck. It doesn't work anymore, because because if you switch this bit, you're gonna have 0 1, and the second prisoner is gonna come in and say, oh, it's in the first square. It's here, but it's wrong. The key is in the 0th square if you want. And so okay, so if you switch the other bit instead, you switch this one to 0, and you're like, oh, it's in the 3rd square. And you come in, and then you're like, oh shit, it doesn't work. So basically, it's gonna work 75% of the time, assuming the warden places them randomly. And then the strategy already is out the window. with 3 squares, it doesn't work anymore. You need to flip one coin, and you have 3 squares. It doesn't work. So I stopped this when I realized that, and I'm like, okay, well, now I'm stuck. Now what do I do? And I came up with these 3 steps it's the 3 steps that we have to figure out for the puzzle, but it just helped me to write them down. The first step was to somehow find some value about the board. Like calculate the board so that the board means something. It could be a number, it could be a word, it could find a value for the current board. So find the value of the board. The second step, still the first prisoner needs to send information. You know, or flip one coin. And the third one needs to find the value again, in the same way. Find a new value. And this new value will tell us where the key is. And this was the steps that you have to do. It's easier said than done, right? But this is kind of the strategy I was going for. And now we're gonna go with my super complicated method. Alright, so here's the first kind of math heavy, super complicated version. If you want the simple, elegant version, I'll put, you're gonna have like chapters in the video, and you can skip to that one. This one is a bit more math heavy, but it's concept heavy. It's not math heavy, right? It's gonna be very easy to understand, but to do the math, but it's just a bit abstract, a little bit. So what I decided is try different ways to calculate the value of the board. The first one I tried was obviously, okay, I'm gonna calculate all the tails and I'm gonna come up with a number. Let's assume I look at this board and it's gonna be like 27. I don't know. And I like, okay, if I have the power to flip one coin, I can either change that number to 26 or change that number to 28. And that doesn't help me at all. I'm like, okay, I have no power. So if the key is in the, for example, 8, 9, 10, 11, 12, 13, how can I get to 13 with 20? So again, that didn't work. So I need to find another way of counting. And I'm like, okay, remember at the beginning, I told you that one coin, one coin can represent 2 squares. And 2 coins can represent 4 squares if you count in binary, right? 0 and 1, and this one 0, 0, 0, 1, 1, 0, 1, 1. So you have this. Obviously 3 coins, you can go even further. So how many coins do I need to have information about 64 squares? And the answer is 6. I need 6 coins to get 64 squares. So now I have 6 coins. So I have a 6-digit kind of binary number. And I decided, okay, let's all assign them one binary number. So I'm just gonna do the first row up to the key. So the first one obviously would be 0, 0, 0, 0, 0, 0, and then I count up 0, 0, 0, 0, 0, 1. And I do this for all the squares, technically, right? 0, 1, 0, 0, 0, 0, 0, 1, 1. And then 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, and finally 0, 0, 0, 1, 1, 1. And then when I switch row, I'm gonna switch again. 1, 0, 0, 0, 1, 0, 0, 0. And then I just do the same thing, but this time I have a 1 here, 0, 0, 1, and then 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 1, 1, and finally where I'm at the key, 0, 0, 0, 0, 0, 1, 1, 0, 0. So my key right now is at the position 0, 0, 1, 1, 0, 0. Okay, so this is what I need to send to the second prisoner that it finds out where the key is. If the prisoner somehow get this number, they can count up, like I did, up to the square, and like, okay, the key is here. And they will find the key. So now comes, okay, I know what information I need to send. The problem is, how do I send that information? And it's it's the beauty of it. So what I did, the very math heavy version of it, is I'm gonna do on a little tangent here and explain what binary addition is with a XOR function. And it's very simple, don't worry about it. You don't need to, it's not on the test, you don't need to remember it. XOR, what does this mean? It's mutual it's kind of mutual exclusion, basically. So this only means one or the other, but not both. So let's say I do 0 XOR 0, this is gonna give me 0. If I do 1 XOR 0, so it's one but not the other, I'm like, okay, this is true, this is fine, I got 1. The same thing on the other side, I'm like, oh, this is great. But now if I have both, then it's 0. So basically you can translate that as a plus sign. 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, but this one, basically, when you do binary addition, like if you do 1 plus 1, you're gonna be like, oh, 1 plus 1, this is 0, and there's a little carry 1 here, and you got 10. But this, all this does is ignore this, and you get 0. So you do addition, but you just ignore the carry, and this is what's left. So this is what I'm gonna use, and this is the only mostly complicated thing. And I decided, okay, I'm gonna take the value of the coin, the same thing, h equals 0 and t equal 1. So I'm gonna take the value of the coin, I'm gonna call it v. I'm gonna multiply it by their number. I'm gonna write it like this, so it's kind of easy to see. And then I'm gonna add, which is XOR, the other one, the value of the second one. And this is gonna be 0, 0, 0, 0, 0, 1. And I'm gonna do this, as you guess, 64 times in total. As soon as you look at this, it's like, okay, this is complicated. I don't like this. This is gonna take way too long. Like, the math is not hard. You do one multiplication and just add this special addition here. At the end, it's gonna give you a 6-digit number, right? So let's add another one just for an example. 0, 0, 0, 0, 1, 0, and 0, 0, 0, 0, 1, 1. So let's assume I'm adding this one and this one, then 1 plus 1 is gonna be 0, 0 plus 1 is gonna be 1, 0, 0, and all of these will be zeros. This is what I'm gonna get if I add these two together, right? I'm just doing addition, but bit by bit, right? And at the end is gonna give you an answer. So just for the sake of example, let's say that the answer is 1, 1, 1, 0, 1, 1. let's just assume that this is the final answer. I don't know what the answer is. I won't calculate it because it's gonna take a while, but okay, so let's assume that's the final answer, and I want to get from this to this because this is where the key is. So this is where the key, and this is the value I get from the board, from step 1. Now I need to do something here, flip a coin in such a way that instead of this answer, I get this answer. And the easiest way to do this is you just need to flip the coin where you change all of these. And I know it's complicated seeing that way, but I have this value. I want to change it to this value. And what do I want to change? And I'm gonna put a 1 where I want to change something, a 0 and where I don't want to change something. So for this first bit here, do I want to change it? Yes, it's 1, I want it to 0, so I'm gonna put 1 here. On this bit, do I want to change it? Yes, I want to change it, so I'm gonna put 1 here. This bit, do I want to change it? Yes, I want to change it. It's 0, I want it to 1, so I'm gonna put the 1 here. Same thing, I'm gonna do this. This one I don't want to change it. It's 1, it's already 1. This one I want to change it, and this one I want to change it. And that's the value I get, like the calculated value that I get. And I just count up to this coin and flip it. And if you do that, you do the same calculation again you just did, but this coin is going to be flipped. So the V value that I decided is going to be like, and you know, if it's 0, this is going to be 1. If it's 1, this is going to be 0. You just switched the value of V. So you either add it or remove it. And if you do that, and the second prisoner comes in, does the same calculation here, they're going to get this number and find the key. So you're like, okay, it's solved. It's super complicated, but it's solved. Now I'm going to explain why that works, and this is the really fun part of it, is why this works. And to explain why this works, I'm going to show you now the easier and more visual explanation, and you'll understand pretty much why that works. Okay, so we're back at the board. The only thing that we're gonna keep from the previous solution is the fact that we're numbering each and every one of these coins and of these squares and the coins with the binary number that goes with it, the 6-digit binary number that goes with it. It's important that it's binary for this to work. And this is the solution. So basically what you're gonna do is you're gonna take, we want to find the value of the board bit by bit again, right? I want to understand which, is it a 0 or a 1 that goes here? Is it a 0 or 1 that goes here? We're gonna do it bit by bit, and we're gonna do it in the most simple way possible. You're gonna ask yourself which squares affects this bit, and how we're gonna calculate it is we're gonna add all the tails together, and which squares do I need to add to affect this bit? And basically it's gonna be 3 patterns. You're gonna remember 3, all you have to remember is 3 patterns, and you solved it. So everything in this row has a 1 bit at the end, right? It's gonna have a 1 bit at the end. Everything in this row, everything in this row, and everything in this row. These rows do not affect that bit at all. So all you have to do is count the amount of time you see tails in these 4 rows. And you're like, okay, I see you. I'm gonna switch colors here. I see one here. I see one here, and that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got 16 tails. Is it even or odd? It's even, so I put a 0 in. So all you have to remember is the pattern, and if it's even, then you put 0. If it's odd, then you put a 1. And if you remember, like this famous XOR thing I was talking about, it's the same, right? If I have a 0, then right, it's even. 0 is even. You don't have nothing, right? If you have 1 here and you add it with a 0, then at this point you're like, okay, well, I have 1 1, it's odd. Same thing if I do it the other way. I have only 1 1, so it's odd. But if I have 2 1s, it's even. I have 2 of them, so it go back to 0. This is basically what you're doing, and that's why it works. It's because you're counting basically what I did with all these huge equations that I was doing. I was basically counting for each of these 6 bits. Do I have an even number of them or not? And that's the secret of the puzzle, is how to know if it's an even number or not an even number. So at this point you're like, okay, the first bit is even. Now you have a second. This is the first pattern that you need to remember for this to work. But it's kind of logic, because if you number them all, you're just gonna see, okay, which of these squares affects the last bit, and you're gonna find out that it's these 4 columns. And then you're like, okay, now at this point, which one of these squares affect this bit and this bit only? And you're gonna find this pattern. These two don't. It's always 0 here. These two don't affect it. These two affect it. These two don't affect it, and these two affect it. There's a 1 here. This one, there's a 0 here. This one, there's a 1 here. And you're like, okay, and we do the same exercise, but this time for these 4 columns. And we just count the number of these. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's even again. So it's even, we put 0 in. So at this point, if you know the pattern, in like 2 minutes, less than 2 minutes, actually, you figure out what it is. And now the third pattern that you need to know is which one affects this bit. And you're gonna figure out that this one doesn't affect it, right? This one doesn't affect it. This one doesn't affect it. And this one doesn't affect it. And all of these have a 1 here at this spot. So all of these affect it. And then you count again the number of T's in these 4 columns. And you're like, okay, 1, 2. Oh, I missed one here, I think, before. 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It doesn't affect it, it's 0. So let's just go back. I'll go back quickly and recount. I'll speed it up. I'll just recount this step. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's one more. This is odd. So this would be 1. I just missed this one here. So this is 1, and then the same thing. I'm just gonna check these 2 just in case. Okay, this is even. And finally, these last ones that we calculated, I think it's even. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's even. So this is the current thing. And now you're like, okay, well, you said 3 patterns, but I only have 3 bits. I need 3 more. And you're like, and it's really simple. It's the exact same thing, but with rows instead. So remember the first pattern, it was no, yes, no, yes, no, yes. It's the same thing, but you're gonna do it the other way. No, yes, no, yes, no, yes, no, yes. And you're like, okay, so you just count the tails. And you're like, okay, so this is, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's odd. There's a 1 here. And we do the same thing, just for fun. No, no, yes, yes, no, no, yes, yes. That's the second pattern. And you're like, okay, and yeah, you count the T's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's odd, so we add a 1 here. And finally, the last pattern. It's these last 4 rows. No, 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 no. And you just count the T's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's even 0. This is the current value of the board. And we want to get this value. 0, 1, 1. 0, 0, 1, 1, 0, 0. So let's do it pretty here. 0, 0, 1, 1, 0, 0. And you ask the same question. What do I want to change? Do I want to change this one? Yes, I want to change it. I don't want to change this one. I want to change this one. I don't want to change this one. I want to change this one. And I do not want to change this one. And finally, you flip this coin. Because that's what you're doing, right? There's a uneven number of tails right now. And if you flip it, there's going to be one more. So now it's going to be even. That's all it means. There's an even number of this bit right now, so I'm not adding more because I don't want to change it. So it's going to stay even. There's an even number of this one, but I want an uneven number, so I'm going to flip it. And I change it. It's going to be uneven at the end. And the same thing goes for every one of them. There's an uneven number of this bit. I want an uneven number of this bit, so I don't change it. And that's it. So now I'm going to go to this square. You can either count in binary, it's going to take a while, or you're like, okay, well, I know it's in this first pattern, because I know, that's the pattern I counted, so it has to be in one of these 4 rows. It's not in the second pattern, so it has to be where it wasn't. So yes, so it's not in this row. It might be in this row, and it's not in this row. And then finally, it has to be in the last 4 blocks, so it has to be in this row somewhere. And so now you do the first pattern, so it was no, yes, so it could be this one, no, yes, it could be this one. I'm gonna change color so that it's more, it can be this one, it can be this one, it can be this one, or it can be this one. And now, oh, sorry, it's not in that, it's not in that pattern, so it's where it doesn't affect it. So it can be this one, this one, this one, and this one. and you're like, it has to affect the second one, so it's in the second pattern. So no, no, yes, yes, so it can be this one here. No, no, yes, yes, or it can be this one here. And finally, it's not in the last four, so it's this one here. You flip this bit here. So this one, from tails, you switch it to head. You flip this bit, and now if we do the same exercise we did here, we can do it together or not. We're gonna reach this number here. So so you flip this one, the first prisoner go away, the second one comes in, does this first exercise, and gets this number, and they figure out where the key is. And that's it. That's the solution. It's, for me, it's brilliant because you have a seemingly impossible set of circumstances, and you have an easy way to do it. Like, you can do this without calculating stuff. All you did was add up all the t's, and you're done. You just memorize these 3 patterns that are very easy to remember, and alternating, then twice alternating, and then 4 times alternating, and you're done. You do this for the columns, you do this for the rows, you figure out if it's even or odd, you figure out if it's odd or even, and you just flip the one that switches them to the one you want, and you're done. So the first prisoner has a little bit more work to do, but not that much. And the second prisoner comes in, just calculates the number of t's in each of the patterns, and figures out where the key is. It's frustratingly simple, but it's the cleverness of it. Like, you have to think of binary for first thing. You have to think in binary. Once you figure out the binary part, you're like, oh, that's just parity. You're just calculating if it's even or odd. I did the same thing here with my huge equation. I was doing this concept without even knowing. And that's why I was kind of frustrated when I saw this. I'm like, oh my god, this is way simpler than my huge math equation and calculates 64 times. And you're like, oh shit, that's the solution. Well, I hope you liked it, and remember, there's a puzzle like this, I strongly suggest that you figure out what the solution is. Try by yourself first, because this kind of puzzle, it's gonna take years to forget what the answer is. It's very, very difficult, but very, very clever, and it's purely math-based. And it's very simple math. All you need to do is know how to add stuff, and to ignore the little carry that you do, and even then, like in this simple solution, you didn't even think about the carry and stuff. You just count if it's odd or even. And I just showed it to show you where this odd and even comes from. But that's it. I hope you enjoyed my little presentation, and let's hope you understand. If you have any questions, let me know. I want it to be like super clear, and that's it. Oh my god, that's 44 minutes to explain this. Here was like, oh, in 10 minutes I'm gonna show it to you, but the last part might be just 10 minutes. So yeah, hope you enjoy, and see you next time. Alright guys, editing Dax here. I'm just gonna do a very quick example. I just generated a random board with zeros and ones, ones being tails and zero being heads, and I've hidden the key in this square. And now the first prisoner comes in, see where the key is, and see this board. So let's do the same calculation, basically. So remember, all I did is quickly did the formula for the first pattern. So remember, like all these rows, this is the first pattern, this is the second pattern, and I'll try not to mess up my formula here. So this is the second pattern, right? And this would be the third pattern, all these four. And now the same thing for the rows, all these pattern, this pattern, and the last pattern, these four ones. So this is what it gives me. All I use is the is_odd function. So if it's odd, it's gonna say true. If it's even, it's gonna say false. So we can do the thing here. False is gonna be 0, 1, 1, 0, 0, 0. So in our case, we can use and we read it from the last pattern, so it's going to be 0, 0, 0, 1, 1, 0. I can do this, and this is going to be my first number. This is the current value of the board, and I want to flip. A coin so that it gives me this value. The key is in this value. I calculated for you. This is the value of the key right now. It's the 43 square. So that this is the square number 43. If I start here at 0, 0, 1, 2, 3, 4, and you go to 43, and this is the square that you want to. So what bit do I want to change? It's really simple. I do want to change the first one. I don't want to change the second one. I want to change the third one from the left. I want to change the fourth one from the left. I don't want to change the fifth one, and I want to change the sixth one. This is what I want to change. All right. I don't need the apostrophe since it starts with 1. And this is what I want to change, so that's the value I get. So now I just need to count up to this square and see after the flip if it gives me the total will give me this number, right? So this one, so let's see, is it in the first bit here is 1. From the right is the first bit is 1, so it's located somewhere in this first pattern, right? That's good. The second bit is 0, so it cannot be in this one or in this one. So we're left with this one or this one. So this is the one that we're left. The third one is 1, so it is in the fourth pattern, so we know it's in this column. So we know it's somewhere here. So now the row, it is in the first pattern, so we know it could be this one, this one, this one, or this one. And it cannot be in the second pattern, so it cannot be this one, and it cannot be this one. We're left with 2. And it is in the last one, so this is the bit that we need to flip. This is the one, right? So there's only one that corresponds to this one. And if we know this one is 43, we can just, make sure that we didn't mess it up. Binary to decimal, this number, it should be like 45. Yeah, 43, 44, 45. This is exactly the one we have. So we're going to flip this bit from 0. We're going to switch it to 1. And now we're going to see if this number matches this number. So here we have 1. That's good, right? We have 0, 1, 0, 1, 1. And if we write it down from top to bottom, we have 1, 0, 1, 0, 1, 1. And there you go. It works. So now, when you do this exercise again, the second one is like, oh, this is the key, and there it is. So this is just to show you the solution worked. and it's very simple. So yeah, that's it.